And then going to share screen. Where is that? This one. Stop sharing. Okay, so what we are going to do today is first let's continue our discussion about the case study. If you recall, you remember last class, hold on, need to go to the waiting room. Okay, so we are going to continue our discussion about TMDB, that movie dataset study. And I remember last week we finished the first part of investigation, okay, about general explore, okay. So it discussed popularity over the year and how the distribution of popularity in different revenue level, etc., and the score regarding versus the revenue level. So that's what we discussed last week. Today, let's try to finish both part 2 and part 3, okay? And for the part 2, what it's going to investigate is try to find out what the feature associated with movie that has high popularity, and also want to find out the feature that's associated with movie have high voting score. Okay, so that's part 2 research. So let's move to part 2 research first. Those we already discussed last week, etc., and we discuss. So this kind of tells us how you write for your final project. Okay, so data cleaning and then starting data analysis, and has some visualization, and you also have some summary for your findings. Okay, so the second part. Okay. For the second part, what it's trying to do, find the feature that's associated with movie have high popularity, etc. And here the author said there are 2 types of data. 2 types of, one is quantitative data, okay, quantitative data, like revenue, etc., like budget, runtime, those things are the quantitative data. And for quantitative data, what the author did is to divide the data into 4 different levels based on their quantile, like low, medium, is it, and higher, like those. And based on the quantile, and if you recall over here, basically what the author used. So that's a kind of strategy we can also use. If you remember the general information about your data frame, is it? Regarding that, the describe part will return you what? Will give you what is the minimum for the quantitative, is a minimum, and the 25% quantile, 50% quantile, 75% quantile, and the maximum, is it? So over here, from the minimum to maximum, it's already kind of divided into different levels, is it? So over here, what the author uses this different percentage quantile to divide the quantitative data into different levels, okay? Make use of that to describe whatever it returns, the data frame. Okay, so that's the concept for the quantitative data. Okay, there's some also categorical data for the data analysis in this case. The categorical data, most interesting stuff we we are looking into is like the cast, director, is it keyword, genre, is it those things. So you want to find out who is the most popular cast, the most popular director, is it the keywords you're interested in looking for, and what's the genres that will contribute the most to the popularity or the high rating, etc. So we also want to do something like that. But those data are category data, they are string, etc. So how do we do that? So let's first take a look. So for the quantitative data, what the author did over here is define the quantitative division function. It's called cut into quantile. Okay, so you're going to have the data frame as one parameter, and then you're also going to define on which column, so on which feature, you're going to do the different level of the division, etc. And if we take a look, you will find, is it get the minimum value, is it? And then how did it get the different quantile of data? It uses the describe, is it? And describe, then you specify what is the describe returns. You remember it's also a data frame, is it? And then you specify certain row, is it? Then you can get 25. So this is 25% quantile, this is 50, this is 75, is it? Then in this case, we get off the different level of the data, is it? And then we can put them into different bin, is it? So you specify the interval. So over here, you specify the interval edge, okay? The bin edge, okay? And over here, we also label our bin with the different name. Is it low, medium, moderate, and high, is it? And then you can call pandas cut function, okay, with whatever the column data you wanted to cut into different bin, basically into different intervals, is it? So that's what this function does, okay? And the second function, what it does is regarding categorical data, okay? And what this function is find the top. So you want to find who is the top cast, who is the top director, something like this. And the parameter is whatever the column, okay, the feature. And over here, you also want to find the top one or the top two or the top three or the top five, like actors or actress, or top five directors, is it top five keywords, top five genres, something like this, is it? So the second parameter in this case is regarding the number of the top specific target you're looking for, is it? So how do we do that? And if we take a look at the original data, let's take a look. Let's find the original data, something. Oh, we need to scroll up. Yeah, over here we can kind of see. Okay, over here, take a look. If you take a look at the cast, if you take a look at the cast column, if you take a close look, you will find, did you see? Okay, it has Chris, and then what follows is Patty and Bryce, and between it has a vertical line, is it? And then it's moved to the next line, and then over here it has Howard, and then vertical line. It has some vertical line, is it? So this is all strings. Is it? This we consider them as categorical data, is it? And if you take a look at the keyword part, it's similar. Is it? It also has a lot of the vertical line. Is it? Vertical lines. Is it? So yeah, so you needed to take a close look of the original data, is it? Then you can find a way to deal with it. So let's take a look at that function. Okay, the find the top, is it this function? I just mentioned, is it its purpose is to find who the top director or cast are, those things. So over here, because those are categorical data, a string, is it? So in Python, we know for string, the split function, is it? You want to get each word out, is it? And then you can call the split function. It's over here because different director or cast, is it? They are separated with that vertical line, is it? So you can specify what the splitter is going to be, the delimiter. So in this case, delimiter. You need to specify. In this case, it's that vertical line, is it? And of course, the first case, you're going to concatenate because it involves multiple lines. You're going to get all of them together, is it? Okay, and build and with that, then you call the split. Then you can get each word out. So you have a word 1, is it? And then word 2. And then you're going to have this list, is it, with this split function. Okay, so that's what that part did. And then you can use it to build a new data frame, okay, with a dictionary. So over here, it's a dictionary, okay, to create a data frame. And then because over here, what we interested is what? Is a top 3. Is it? This is by default is top 3. You can override it with top 5 or top 1. Is it? So the number if you want to override. Then what we can do is you remember previous we learned you can do value counts. Is it? Then it will count how many times, like suppose the director Spielberg. Is it? How many times Spielberg occurred in all of your data frame? Is it a specific column? Is this suppose the director column, how many times it appears? Is it? So then he will be the top director, is it? And then you will get what? Over here, I'm going to get the top 3 or the top 5, is it? Or the top 10. So that's over here what this find the top function does, okay? And then let's see, over here, what it says is the first step the author did is going to filter out the top 100, the worst 100 movie in each year. Okay, that's what it's going to filter out. Okay, the popular top. So first it's going to top 100 popular movie in every year. Okay, so how does it do it? It's called the sort value function with the data frame, is it? And it's going to sort by what? First by release year, okay? Second is going to be by popularity, okay? Then you're going to arrange it in certain ascending or descending. You can specify true or false, is it? And after that, you're going to group by the release year, okay? Because I'm only going to be interested in top 100, is it? That's why over here you can get the head of 100, is it? And over here it shows the top 5, okay? But this DF top P, it will give you the top 100 popular the popularity, regarding the popularity, okay, it's a top 100. Then over here we have some brief information, is it? And what next is similar. It's going to get the top 100 revenue movie. So this is regarding revenue this time, not about popularity. It's similar. Then you're going to do the group by, okay? And the same thing, you're going to do the score, top 100 high score. Then in this case, you're going to do the sort value by vote average, okay, the score. And then we are also going to find what? Find the least, is it the least popular 100 movies, the least revenue 100, the least regarding score, the 100, is this the last one? Okay, so similar steps as what we just did. Okay, those are regarding what we collected about 100 top and the least 100 popular. or the revenue regarding the specific feature, okay? So those are the information we already collected, get them to different data frame, okay? And what next, what we are going to do is, because we want to know what a feature associated with high popularity, etc. So how do we do that? So the very first thing is we are going to call that cut into quantile method, the function that we define. Is that we pass in our data frame. We are going to use budget to do the quantile cut, separate them into different levels, etc. And after that, after you define with that, then what you're going to do, whatever you receive, etc., of the data frame, you're going to group by the budget level, etc. The budget level, then with regarding what over here we are going to do the group by as using what? Using the popularity, but you're going to group by the budget level. The budget level is what? Is we already divide them as the lowest 25%, between 25 to 50%, between 50 to 75%, is it? And between 75 to maximum, is it? The different budget level we already divide, is it? And over here, you're going to group by using what value? Using the popularity score, is it? And the group by, we said, is going to do some aggregation, is it, over here? So over here, we are going to do the mean, okay, based on each different group. So here give us some general result, okay, of our the different level, okay, the popularity distribution with the different budget level, okay. And over here, we also try to find the median, okay, regarding the different budget level. So that's regarding that popularity versus the budget level. Then what next we are interested, generally speaking, is we want to have some visualization result. That we want to see how the popularity distributed with the budget levels, visualization. So how did we achieve that? So let's see. So we are going to have some bar plotting, okay, bar plotting. And in this case, we are going to do the mean part of the budget, okay, already separate into different levels, okay. So we are going to collect, okay, how many different levels we have, and here define the width of the bar, is it? Okay, then we are going to use over here, it's the C-bar, okay. For the C-bar, we are going to set the style. It's we are going to use the grade, is it? And it's dark grade, so we pick that. Then we are going to draw our bar, is it? So we are going to do bar drawing. Bar drawing, then what's the X and Y value, is it? So X is going to regarding different level, is it? And the Y value is going to be what? Is a popularity, is it? And then you'll also specify your bar's width, is it? And the bar's color, is it? And the transparency and the label, is it? So all of those information. And then you are also going to specific add some title and the label, is it? And the text, okay, and the legend. So then you have this visualization result, is it? So with this visualization result, you can see it's quite obvious, is it? So the popularity increase, is it? With how much money you spend, is it? Yeah, so this tells us the result about the popularity distribution versus the budget, okay? And then what next? You also interested, okay, the popularity with budget. How about the popularity with the runtime? So how long the movie it is it? So can we do the same thing? Yeah. So it's pretty similar, is it? So here is a visualization result. And from this visualization result, you can see it's also increased, is the runtime, is it? Yeah, because a lot of very good, like Star Wars, it's also quite long, is it? And if you think about Star Wars, that movie, the budget is also huge, is it? So, but it's very popular, is it? So it's kind of, we can also verify with some examples. Okay, so this part shows us how do we do some quantile percentage split. Then you can have your data in different levels. Then you find some relationship. Okay. What the next part is about the categorical data. Is it about cast, direct, keyword, genre? Is it and the production company? Is it? We also interested in some of those information. Is it? And over here, try to get previously. Remember, so previously we did that top 100 and the list popular 100, those findings, is it? So here give us some glimpse, is it? And once again, over here, we have that vertical line, is it? To separate different people, is it? And over here, the keyword, is it? Regarding the movie, also separated with the vertical line, is it? And okay, with this, is it? Then you can do the specification, is it? So what you want to find, is it? So in this case, for this A, is it? What it return? Return a data frame, is it? A is a data frame. What this data frame is going to find is from that top 100 popular list, is it? Find what? Find the cast. Okay, and the B data frame find what? Find the top 100 popular movies director. Okay, and the C is going to find the top 100 movies, popular movies keywords, and the genres, and the production companies. Is it? And over here, we didn't specify the number, is it? So all of here is going to use the default values, is it? Default value of 3, is it? So it's always going to be find the top 3, okay? So that's what this part means, okay? You call that method. Okay, you can find of the top 3, okay? And what the next part shows is then with whatever we just find the top 3, is it? Top 3 cast, direct, is it? And you can use it to build a data frame, is it? Over here, we use dictionary, is it? To build a new data frame, we call it popular, is it? Then over here, it shows us, is it? The top 3 cast, the top 3 director, keyword, genre, and the producer, is it? And for the same thing, for the lowest, is it? The least popular 100, then you can do the same thing, is it? So find the most unpopular, okay, cast, director, is it? But if you compare both of this, the top 100 popular list and the least unpopular ones, you will find some interesting things. You will find the popular and unpopular, they have some overlaps. Yeah, if you take a look, the most unpopular cast, Clint Eastwood is here, is it? And how about over here, Clint? Oh, it's not in the popular cast. Let's find the popular director, unpopular director. Unpopular director, we have Woody Allen. We also have Clint Eastwood, is it? But if you find popular, both of them are also on the list. So it's quite interesting, is it? And the same thing for the unpopular keywords, is it? We have what over here shows, is it? And the popular keywords, and the popular genre and the unpopular genre. So unpopular genre, you can find the drama is one of it, and with popular, it's also one of it. Yeah, so you can see the finding is quite interesting, is it? So that gave us some interesting information. And so this is regarding the popularity, is that we can find out the features that will tell you the popularity, relationship with popularity, and from like the cast, etc., or the director or keywords, genre, and the producer, etc. And we can do the same thing with the voting score, okay? We can find the voting score, do the similar thing. And for the voting score, if we do the same thing with different budget level versus voting score, and you will find it looks like it doesn't impact a lot, etc. So it's different scenarios. The budget has impacting regarding the voting score. And the runtime, same thing. You will find the runtime doesn't impact a lot regarding the voting score, okay? And then over here, same thing. The previous one we discussed is about the categorical data regarding versus the popularity. Then here you may also be interested in how about those categorical data like director, keyword, and genre associated with voting score, is it? So you can do similar thing, is it? And it will tell you some result, is it? Then you can do your analysis and do the report part, okay? So that's what the second part did, okay, second part did. And then next, let's see, the third part is also quite interesting, tell us some techniques when we do the data analysis, okay. So the part 3 is find the top keyword genre trends by generation, is it? Yeah, so the first question is then, because over here the data collected from 1960 all the way to 2015, is it? So we also want to know, okay, based on different generation, what the trend it is it? So those are also interesting questions. Okay, so then the first question we want to know is year by year, how many movie is released, is it? We want to know those information. And also we want to know the keyword trend by generation. Is it genre trend by the generation, is it? So what over here the author said, it's going to find out the number of movie release years. This is kind of easy to achieve, is it? And for keyword trend, the genre trend by generation, so here we need to do something, is it? Because we interested in about the 60s, 70s, 80s, 90s, 20s, is it? So those different generations. So then in this case, we also need to do some grouping, okay? So let's see how the author achieved that, okay? So regarding the number of movie release year by year, is it? Then we can apply pandas group by. Group by, as previously we keep mentioning, it's a very useful method, is it? So here we do group by, but group by, generally speaking, after you do group by, you're going to do some aggregation, is it? So in this case, we are going to do the count aggregation, is it? And here it gives you some general information, is it? Each year, how many movies it's released, okay? So quite useful information. Then we also wanted to do some drawing to reflect the trend, is it? So over here we use Seaborn again, okay, use the dark gray. And then you're going to have the release year as X value, number of movies released as Y, is it? Then we just do regular plot, is it? So it's just some curve, okay? And you can also specify title, label, is it? So we have this result. So from the result, the visual result, it's quite clear, is it? The most recent number of years, number of movies released grows more. This, I believe, personally believe, it's also because of digital, the computer, is it? Also helps a lot with a number of movies, because now you can do the digital shooting, is it? Versus the older traditional way. Okay, then what next we interested is in regarding the trend by generation, okay, trend by generation. So then how do we define the trend by generation, etc.? So then here you want to get some general idea about the number of year distribution, etc., so that you can So here we define, okay, we said we are going to get of the year, okay. So from release year, you get only unique, is it? Then we sort the year, is it? So here we have the year's data, is it? So it's a series, okay. And then you can define, is it, each list of the year, 60s, 70s, is it? So we can do the slicing, is it, to get off the years. And then next, let's see. So this is just some review of our data frame, okay? And then over here, so we have the list of the generations, that we also gave the name of the generation. And what next we did is we have this loop within each generation, is it? And within each, then you're going to do record by record check, okay? So over here, it's each row. Over here, it's each row in your original data, okay? In original data, okay? Then you check if that year is within, this S is from the 60s, 70s, is it? Is within that generation. So each generation over here. Okay, and if it is in that generation, is it? So you're going to get off the data, okay? That's how you get off the data off. And then we are going to create a new data frame, okay? This data frame is going to be based on whatever the years, is it? Over here we get, okay? And what we are going to do, we are going to collect the top keywords, and we are only going to get the top one keyword, okay? So we call that find the top function, okay? Get the top keyword regarding that year for that generation, okay? So that's how we do this part. And then after that, is it over here, we kind of show the result, is it? So the result shows up for each generation, is it? For each generation, what you can get, is it? This is regarding the keyword, the top one keyword, is it, for each generation, okay? And how many that generation, how many that keyword appeared, is it, occurred in that generation. So you can collect all of this information, okay? And what the next part to do is, then you can also do some visualization, is it, regarding the keyword trend versus the generation, okay? And if we take a look at this graph, this visualization is quite interesting. You have two, you have the left part of the y coordinate. You also have the right part, is it? We have two. And how do we get some graph generated like this, okay? So let's see. Over here, is it? So we have the list of different generation, okay? And we are going to get our keyword, is it? So this is a keyword. The data frame that we just generated, okay, the top keyword for each generation. Okay, then over here, we are going to know, okay, how many generations we have, is it? So that we can have our X and Y coordinates, is it? So then over here, we are going to draw what? Draw horizontal bar, is it? Draw horizontal bar. And the horizontal bar, the X coordinate, is it? It's what? It's what over here we defined, the Y position, is it? Y position is from where? It's from this generation, okay? So you get the bar X and the Y value, is it? And the Y value is what? Is from the DF3 top. The top is from this data frame. It's a number, is it? Is a number. And over here you see the bar, it shows, okay, how many times this keyword appears in that generation, is it? So that's what we want to draw this bar. Okay, and then you set the label and the keyword, so nothing new, is it? And because over here we want to create another axis, is it? On the right side, is it? So how do we do this? Is you see, it's called twin X, is it? Then you can add that part for the generation, is it? For the generation. Okay, and over here, then you see, for each generation, it's quite the visualization, each generation and what the keyword is also. Both information appeared in this plot, is it? And the number of times that specific keyword appeared, is it? So it's quite interesting information shows us, okay? So that's regarding the keyword trend by generation. What the next shows is genre trend by the generation. So this genre is pretty similar. Is it like what we just did? You also call the find the top, but this time what you just needed to replace is versus keyword, you use genre. Then you're going to have a similar thing and get the similar result, is it? Okay. And so this third part, you see, it gave us the trend distribution by the generation. So quite interesting information, is it? And then you can write some summary, is it, about your findings. Okay, so basically this example we finished, okay, and today we will start the other example. So give us more information so that we know how to do the analysis part, okay. This time, it's another example. This example compares the movie one is not that comprehensive, but this one we will see it also has its own features. This time we are going to see how we deal with JSON file, okay? Because a lot of time from internet, what you get directly is not a CSV file, it's a JSON file, etc. So then how do we do that, okay? And JSON file, I remember previously in our study, I also briefly explained the JSON object concept. Okay, so if you want, you can recall. So the file they get is a plain text file. Okay, but that plain text file it's based on JSON format. So that's why over here, if we import JSON package with Python, then you can directly load the JSON, okay, and then get the record. Then we can convert the record to pandas data frame, okay. So it will automatically handle everything for us. And here it shows the JSON record. For JSON record, it's kind of look like a dictionary, but this is not dictionary, okay. This is a JSON object. And what it has is key, okay, and the key part, okay, the key part over here, it's a string. And over here, the after comma, it can have quite a different kind of thing. It can have string, it can have array, is it? Over here, it's an array, JSON array, is it? It can also have some other JSON object, okay, so quite a different type of data it supports. And then what over here we get off the list of the JSON record, is it? Then we are going to convert them to data frame. And then what over here is we interested in this specific column. It's a time zone, okay, time zone column. And we are going to do some count, okay, totally how many we have, the item. And you can see totally it have over 3,000 items, okay, regarding that. And then it's also going to give us the detailed information that about the different time zone over here it use, is it with each time zone, how many items it has, is it give us this detailed information, okay. So that's regarding this general information about the time zone. And then next, let's see, regarding the time zone, then you want to do some sorting, etc. So we do some sorting, and here it reports the information, okay, reports. So in descending order, okay. And then next is deal some data cleaning work. So with time zone, okay, if there are some null values, you're going to fill with missing, okay. And if it is nothing over there, you're going to assign like the unknown, okay. And after you do data clean, you do some value counts again, etc. for each different category. And then over here, we also want to do some visualization. That you can see with data analysis, visualization plays a very important part, okay. Over here, we also use CBOund to do the draw, okay, and here it does the bar plotting CBOund, okay. And then you just specify the X and the Y value you want to draw with the bar, etc. So the result also give us like this. So what next shows is just you try to get some specific column, is it? This is regarding that A part. Let's go back here. Is it the very first column? The very first column regarding this data, is it? What it gives is, looks like it gives you different operating system, is it? The different different browser, is it, information, okay? And it's pretty old. We can say it's still very old information, okay, Windows NT, okay. And anyway, to give you some browser information, the operating system information regarding that specific column A, okay. So this is regarding the second record, is it? This is regarding the 51st record, and this is, so this is a second record, and this is the 51s, is it? And regarding 51s, everything. And over here, what it does is that 51s, is it? But it will not, if you take a compare, if you compare these two, is it, you will see all of this part cut off. Is it that because over here you do slicing, is it, you don't want all of the remaining stuff, you can do that. So nothing new over there. And what next, what we did is, over here, you are going to regarding that specific column, okay, the specific column. And you're going to do the null part. Is it, if it has any null value, you're going to drop it, is it? So over here, it gave us some, after you do that, what it's going to look like, is it? So you're going to store off the non-null results in a series. And after that, what over here you interested, I want to collect some specific browser information, is it? So you can do the value counts, is it? After I do value counts, you can get a clear picture about different browser, is it? Information. Okay. And what the next part is regarding all of the not null values, you're going to store it in a new data frame, is it? Over here, it's called C frame. And we collect all of those null values, is it? What next is, if you take a close look of the result, you will find it has browser information, is it? It also has the operating system information, is it, regarding that specific column. Okay, then what over here, we can do some filtering work, is it? And the filtering, you're going to check if the string contains the Windows or not. So regarding the operating system part, we're just going to identify it's Windows or it's not Windows, okay? So if it is contains Windows, then you are going to assign it as Windows. If it is not, then you are going to assign it as not Windows, is it? So over here, it shows us regarding this operating system, is it? So you're going to have a specific, you create a new series. This new series will tell you all the information about operating system, Windows versus not Windows, is it? And then regarding that, then what we want to do, we want to group by our data, is it, versus the time zone and operating system, is it? And then the result, you're also going to do unstacking, is it? You're going to rotate your data, is it? So here it shows the result, is it? So the result, it's give us, you see, not window and the windows, kind of give us some grouping information, is it, over here? Because over here we do the group by, is it? So it's quite helpful, is this, versus the number of times it appears regarding windows or not windows and different time zones, is it? Yeah, what next shows us some other useful concept. Okay, so here let's first take a look. So here we have a data series, is it? So just some numbers, is it? 33, some number, and then we also assign our pandas series with index. Okay, the word index. Okay, so here it shows us the result, what it looks like, and then what next over here? Regarding that series, we call this arg sort. So what does this arg sort does? Okay, so here I'm trying to explain this. So here it says arg sort returns the indexes. Okay, but the index will sort the series. So this series will be sorted. Okay, and let's take a look at the result, what it gives you. So here it gives you the result. Okay, and the result, if you see, this is the index, is it? And here is a number. This number tells you the index of the sorting. Okay, after it does a sort, what Coca-Cola should appear. So it returns you the index of the sorted result. Okay, and with this index sorted, then if you apply to the original series, is it? You can sort the original series. That's what this arg sort does. Okay, so we are going to use this arg sort, this kind of concept, to also does what we just at arg cons, is it? Over here, is it these archons, is it? We have the time zone, we have windows and not windows, is it? So we are going to sum of the, so row by row, is it? And then we are going to do sorting, is it? And arrange it. So here is a brief, so here is the result, is it? Here is the result, it tells us. Okay, and then versus that, the arg over here, it also shows us, you can also call the take function. Okay, and what is the take function? It gives you, it says it returns the element in the given positional indexes, is it? And what here, we are also interested, is it? So over here, it gave you, okay, the last 10, is it the result? Okay, and what the next part shows us, you can also call the largest function. Okay, the largest function, then you get the top and largest value from a data frame or series. Okay, so over here, based on that information, so this is regarding each data frame, regarding the operating system, and you sum windows and not windows, is it? And it gave you this kind of output, okay? And what the next part shows is then regarding the result, and you can also do the time zone and the operating system. We can also get the total count, okay? So that's what this part shows. And then the next, based on the provided information, is it, then you can also do some visualization, is it, regarding different time zone and the operating system, is it? And over here, once again, we see with C-bar plotting, is it, you can specify the hue, is it? And what the hue does, it's kind of also give you the grouping information, is it? So over here, then have the separate report regarding Windows and not Windows. Is it because on the operating system you have those two different results? So then your visual result will give you Windows versus non-Windows report, okay, with this bar drawing. And what the last one shows us, it's just a pretty straightforward one. Also, it's just try to do the normalization, okay, with regarding of this previous result. Okay, it's try to normalize the data. Okay, so that's the report of this other case study.